to all, and thank you for joining me in this presentation. My name is Veridiana Jardim, and today I'm going to talk about a part of my doctorate thesis at University of São Paulo. When we talk about behavior, it is important to remember that individuals vary between them in the way that they behave, but these behavioral differences between individuals can remain consistent over time in different contexts, which is a concept in which we define personality. And it's precisely this definition of personality one great limitation of behavioral studies, because to discuss that, one needs to discuss temporal consistency, and for that, we need methods that have repetition in time. We neglect the importance of repetition when working with behavior, not only on personality studies. Aggressive behaviors are shown to be one major component of personality traits, and many studies have shown the correlation of this trait with many others, such as sociability, boldness, proactivity, etc. This trait is specifically important when working with social insects, more so with ants, where aggressiveness can play a major role on nest defense and research for resources. On this study, we worked with an Ectatomminae ant called Gynaptogenes striatula, ants that occur throughout South and Central America. Considering all these factors, our study aimed to answer the question, do individuals of Gynaptogenes striatula show temporal consistency of aggressive behavior? For that, nest collection were carried out on University of São Paulo's campus. In total, 2 nests were collected, and from them, 6 subcolonies were assembled, each one with the start combination of the same workers, larvae, pupae, and eggs. A minimum of 5 foragers were chosen individually marked per nest to undergo aggressive tests. Aggression tests were carried out in a petri dish with the peripheral area marked in pencil. The ant was introduced in an acclimatization tube for 60 seconds, while a hair-specific dead stimulus was placed diametrically opposed at the central arena. Then the tube was removed and the behaviors were recorded for 300 seconds. A circle of 1.5 cm diameter was also delimited around the stimulus to calculate the stimulus peripheral zone. The hair-specific stimulus chosen was a dead worker of Solenopsis sp. This test was repeated 5 times throughout 3 weeks for each individual. All encounters were video recorded. After data collection, videos were analyzed on board software and aggressive behaviors were categorized, and an aggression index was calculated for each repetition for each individual. We also calculated the latency to first intonation and to enter stimulus peripherally, and with that division software, we calculated time spent in different arena zones and the distance moved. From 154 individuals that were initially marked and underwent the first aggression test, only 38 individuals reached the 5 repetition criterion. Statistical analysis were carried out in our software to calculate individual repetition throughout trials. To understand how repetition changes with increasing repetition, we also carry out repetition analysis for 3, 4, and 5 repetitions for the same individuals. Repeatability was found for several parameter tests, starting with our variables with 5 repetition. Looking closely at the aggressive index, we can see that, although repeatable throughout time, aggression was low for the great majority of encounters, mainly because the great majority of interaction behaviors were untonation, that represent an aggression score of 1, or no interaction at all, with aggression score of 0. To understand how increasing repetition can influence on repeatability parameters, we analyzed the same variables with 3 and 4 repetitions. We found that for the p-value, there was not much of an influence on increasing repetitions, for all the values remain statistically repeatable. For the R values, we have a similar pattern, where increasing repetitions didn't impact much. The variable that have shown to be the most affected was the confidence interval. Here we plotted the maximum and minimum of confidence interval values for each variable for each repetition. For all the variables, we see a pattern that increasing repetition lowered the range of the confidence intervals, resulting in a more narrow confidence interval with 5 repetitions, which in turn can represent that our study behavior variables is closer to representing the real behavior displayed by the individual. So going back to our first goal in this study, we have shown that individuals of G. striatula show temporal consistency of aggressive and many other behaviors. Although individuals show low interspecific aggression, a pattern shown in other studies, although being discussed in a different context, such as dominance hierarchy. But still, maybe we can discuss the idea that low aggression is a throughout species trait. Like we said previously, repetition is the base for discussing animal personality, and we've shown that increasing repetition can have a great effect on behavior data, narrowing the confidence interval, displaying more clearly behavior patterns. This, however, go in contrast with the work with Social Spider, for example, that has shown that there was a reduction in repeatability of personality traits over the long term relative to the short term. But in spite of that, long-term personality consistency can be found in many other studies for a variety of species. With these results, we can also discuss that G. striatula is a possible good study species for animal personality, since it can display temporal behavior repeatability for more than one subset of behaviors. We require further testing for other behavior traits to see if this repeatability is also found. That's it for today. Thank you for watching this presentation. Please feel free to contact me if you have any more questions. Bye!